Hello, my name is Vuyisile Ndlovu. I'm a web developer and technical writer based in Zimbabwe. The title of my talk is Using a Raspberry Pi as a Portable PyPI Server. Now, in this talk, I'll talk about what PyPI is, why it's important to know about it, and why you would want to clone it and make your own PyPI server. I'll cover how to go about it, what equipment and what software you need to get, as well as why you'd want to use a Raspberry Pi for this job. So to get started, let's talk about PyPI. The Python standard library includes an extensive set of built-in packages and modules to help developers with their programs. At the same time, Python has a very active community that contributes an even bigger set of packages. These are third-party packages that end up in the Python packaging index, or PyPI. This should not be confused with PyPI, which is a Python virtual machine. PyPI hosts thousands of Python packages. At the last time I checked, it had more than 200,000 of these. Now, packages are organized into an index, similar to the index you'd find in a book. Pip, which is a package manager, uses PyPI as its default package index. That's where it goes first to look for packages. It can also use other package indexes, as we'll see later on. Pip, as I mentioned before, is a package manager. It's one of the most popular ones in the Python ecosystem, and it's a tool that allows you to install and manage additional libraries and dependencies that are not distributed as part of the standard library. So in other words, pip is the tool you use to download and install packages from PyPI. If you've used JavaScript, you know about npm, or if you're from a Ruby background, you know about gem. Pip is like npm or gem, right? Or apt for those who use Linux. Now, all modern Python versions ship with pip nowadays. So let me give you a quick run through some of pip's features. Right, so as you can see, pip allows you to download, install, uninstall, and build packages. So how does it do that? Well, to answer this question, we need to look at a typical installation of a package. Let's take a package like requests, for example, right? Now, to install a package using pip, you would run a command such as pip install requests. If you've used Python, you've probably done this many times before. Now, when you run this command, pip searches for the package, in this case requests, in the PyPI index, right? It determines what its dependencies are, collects those dependencies, installs them, and then installs requests. So this looks something like this, right? You can see there at the top is the command to install requests, right? Now pip in the background will then quickly figure out what requests depends on. In this case, we can see that it depends on certify, URL lib, char.det, IDNA, and a number of other dependencies, right? So pip collects those, downloads them, installs them, and then installs requests. So that's basically how pip works, right? Now, this process is very fast. It's secure, and it works virtually all the time. You may be wondering though, so if I can always get a package through PyPI, why should I make my own PyPI server, right? Isn't that reinventing the wheel? Why clone it if it works? Yeah. Now, I'll give you a few reasons why this might be necessary. There may be things beyond your control that can limit your access to Python package index. For instance, suppose the internet is expensive or unreliable where you live, right? If the internet is not available, that means you can't download packages. Similarly, if there's no electricity, or if the electricity supply is erratic, you can't use your computer or the Wi-Fi, and without Wi-Fi, you cannot download third-party packages, right? A third reason would be if you are behind a security firewall or something at work that prevents you from accessing PyPI. It would help if you had your own copy of PyPI so that you could download packages as and when you need to. And a fourth reason is, well, it would be pretty cool to do it. Yeah, which is why I did it in the first place. Okay, so to create your own PyPI server, you need a few things, and I'll walk you through those in a very broad and general way. I'll walk you through the general steps to take to build your own local PyPI server. And the first thing you need is the hardware, right? And this is a Raspberry Pi. A Raspberry Pi is a small computer, the size of a bank card. The advantage of using a Raspberry Pi is that it's lightweight, it's affordable, it's portable, and it runs on very little power. For instance, I have my Raspberry Pi here. It's pretty much the same as the one in the picture, but mine has a case. It's connected to my computer's USB port, and it's running off that. You can connect it to a power bank, a charger. It needs very little power. And what the good thing about the Raspberry Pi is it costs something like $45 US, and you can pretty much do anything you can with a bigger computer on it. Now, once you have the Raspberry Pi, you want to install an operating system onto it, something Linux based like Raspbian or something, and then we'll use the Raspberry Pi to clone PyPI onto it, right? We'll download as many packages from PyPI as we can fit into the Raspberry Pi. And then the next step is to create an access point that clients can connect to, right? Once clients can connect to the Raspberry Pi, we then allow them to download packages. So this would be very useful, say, if you were running a workshop and the internet is down or whatever, and you need people to download packages. You could use a Raspberry Pi for that. Now, I recommend a Model 3 going up because these come with a built-in Wi-Fi adapter, right? So I'll very briefly go over the steps you need to take and what software you need to install to turn a Raspberry Pi into a PyPI server. So the first thing to do is to get the content. You want to clone the PyPI. Now, I mentioned that there are 200,000 packages on the PyPI, and that's more than a terabyte of data. And chances are you won't get a memory card big enough to fit into a memory card that'll fit all that data into a small Raspberry Pi. So you have to be selective in how you go about it. And the good thing is that there are packages that are useful for downloading and cloning the PyPI. One of them is Mini Repo. Now I like Mini Repo because it allows you to download a selective clone, right? For instance, you can tell it to download Python 3 packages only, or certain types of packages, like maybe you just want to download wheels or something like that. You can filter the packages you want. So that's the first piece of software you need to get. Mini Repo is what you'll use to clone PyPI onto the Raspberry Pi. The second piece of software you need is something called PyPI server. Now this is a Python package that you use to create an index. So when Mini Repo will download hundreds of thousands of files onto and dump them onto your memory card, onto your Raspberry Pi's memory card, and then PyPI server will then go through those files and create an index that allows those files to be searchable. So that speeds up the time it takes to serve up those files. And lastly, you'll need a web server, something like Nginx, production grade. Now, an Nginx will then serve up or make the files available to your users, right? So Mini Repo is a Python package. You can install it by running pip install Mini Repo. After that, you configure it and then run it, and then you can see here, to run it is just simply typing Mini Repo in the terminal, and then this is how you configure it. You can tell it what sort of package types you want, or what sort of extensions you're interested in, or what Python versions to download packages for. In my case, I only downloaded Python 3 packages, and that came up to about 200 gigs of data. Next, you want to get PyPI server. As I said before, PyPI server is also a Python package, so installing it is pretty simple. And after you've installed PyPI server, you'll want to install and configure Nginx, or your web server of choice. Now, I used Nginx because I wanted to take advantage of its ability to handle high traffic loads and caching, right? Now, this results in significant speed ups compared to using PyPI server on its own. Now, you'll see here where I have the arrows. This is where I created the cache, and down here is where I created a reverse proxy and gave my server a name. In this case, I called the server cheeseshop.com. Now, since we'll be creating a standalone local network, you can name it whatever you want. And I don't own the cheeseshop.com domain, and it doesn't really matter because since this is a local network, no one's going to sue me. At least I hope not. Right. So once you've downloaded the content, you'll want to configure the Raspberry Pi into a wireless access point. Right? You've downloaded the content, you've set up a web server to serve the packages. The next step is to allow clients to connect to it. And there's some software you need to download as well to do this. And the software can be broken down to two categories. The first one is to allow the creation of the access point, and the second is to handle IP addresses and domain names. Right. Now, DNS is what's responsible for resolving IP addresses, and DHCP handles assigning IP addresses to the different clients that will connect to your server. Now, these two pieces of software are what turn your Raspberry Pi into a server and allow it to communicate with other clients. So, for access point, you can use host APD, And then for DNS and DHCP, you can use DNS mask. Once those two are installed, you'll want to configure them. So here is we're setting up the Wi-Fi hotspot. So you want to specify what interface you want to have the access point on, and then you want to give your network a name, and down here you want to give your network a password. The next step is to set up an IP address for the server. You want to give it a static IP address so that clients can always connect to it. So in this case, I gave it a static IP address of .4.1, right? And then next, you want to specify the DHCP information. Now, in the previous section, we specified what address with a static IP address, which is going to be the listening address for the DHCP. And then here, you'll set up a range of IP addresses that can be assigned to clients that connect. In my case, I only have about 28 addresses, which means I can only connect 28 clients, but you can go higher than that if you like. All right, so I will show you what this looks like when you've put everything together and you've configured everything. Now, bear in mind that this, I glossed over a lot of the details here, and I'll add a link to a comprehensive blog post that details all the things you need to do to get this to work. But now I'd like to show you how this all comes together. So I have a Raspberry Pi here. It's running, it's on, it's broadcasting a Wi-Fi network that I'm connected to, and it has all the Python packages that I need. So what I'm going to do now is throw up a terminal. I have a terminal here, and I have already created a virtual environment. So I'll activate this virtual environment. All right, so the virtual environment is active now. And just to prove to you that it's a brand new virtual environment, I'm going to run pip list. Right? As you can see, nothing installed there except for pip and setup tools. Okay, so I have the Raspberry Pi running here and I'm connected to it. It does not have internet access, so I can't just do pip install requests or something like that. So you remember I mentioned before that pip can install packages from third-party indexes or indexes that are not the Python packaging index. So if you want to do that, you simply specify or let it know that you're installing from a non-default location. So how you do that is by using a flag called trusted host. So the first thing you want to do is tell it that you're installing from a host that it can trust. In this case, our host is cheeseshop.com, right? And then we want to install, I already have install here. Install, and then we let it know that we're installing from a third-party package index called http://cheeseshop.com. Okay, and the name of the package we want to install. In this case, that's requests. So I'll hit enter right now, and what's going to happen is pip is going to go through the local package index, search for requests, and install it if it finds it. Okay, let's give that a go. So it's looking in G shop, it's downloading the dependencies, and it's installing them, and then it's done. So if we do a pip list now, you find that request is installed. Okay, so let's try something else, a new package, something bigger, say Django, right? Go. It's looking for it, and it's installing it. Boom. Right? Okay, so I'll try something else now. Let's try Flask. Right? And there you go. So as you can see, this is just as fast, if not faster, than using PyPI. The reason for this is the request doesn't go through the internet and back. It's a local request and just goes to the Raspberry Pi, and Nginx serves up the file real quick, and it works just the same. Now, if you're interested in learning more about how this works and how to put it together, I have a blog article on my website at vuyisile.com/blog. If you want a short link to it, it's bit.ly/PyPI_in_box. Visit that link. It will redirect you to my website, to the article on my website that details how to create your own Raspberry Pi server. You'll find links to documentation, configuration instructions, and a few more things that I didn't cover in this talk. At this point, I'd be very happy to find out if you have any questions and answer any questions you may have.